Alright guys, welcome back. This is the last video for this week in wrapping up simplifying rational expressions. And in the last video we had talked about how to multiply through expressions. And in this video we're going to talk about dividing. And as soon as people hear that, I think we kind of instantly all get this like pit in our stomach of like, oh my gosh, it's going to be so much harder. But remember that dividing is the same thing as multiplying by a reciprocal. So we're going to do a trick where we just turn all of these into multiplication problems, and then it's pretty much the exact same thing that we did last time in the last video. Just a few things I want to talk about with domains. So it is important just to follow along to make sure you're getting attention to detail, because that'll make some of your answers wrong versus right, is some of the attention to detail. Okay, so to remind you of what multiplying a reciprocal is I can change this problem 3/4. Instead of dividing by 12/7, I can multiply by 7/12. And that gives me the exact same thing. The reason that works is because if you look at this and you think, oh, well, let me get rid of the denominator, you'd multiply it by the reciprocal to cancel all that. And whatever you do to the bottom, you have to do to the top. So as just a shortcut, you could say, well, why don't we just forget this and go straight to this part where you multiply by the reciprocal. And that's exactly right. That's exactly what you can do. So when you do that, 3 times 7 gets you 21. 4 times 12 is 48. And then I would just see if you can reduce that. I would literally type that on my calculator, hit math frac, and you would see that you get 7/16. So that would be my final answer. Okay, let's do part B. So I'm doing 4. Remember, 4 is the same thing as 4 divided by 1. And I'm dividing by 5/3, which means I'm timesing by the reciprocal, which is 3/5. Multiplying the top gets me 12, and the bottom gets me 5. So as you can see, when we divide complicated things, it's just a multiplication problem, and it turns pretty easy really quickly. So let's see how that can apply to Algebra 2. This first property is just telling you, hey, when you multiply, that's the exact same thing as just multiplying by a reciprocal. And that's all it's saying here. So that's just recapping what we did in the first slide. This bottom part shows you how it applies to Algebra 2. If I ask you to divide by this, well, just flip-flop the top and bottom. So just take these and literally flip-flop them and turn that into a multiplication problem. And that's what they did here. They flip-flopped exactly what I have circled in blue and put a multiplication sign in between instead. Then it turns into exactly what we did last time, where things cancel, which is nice. Alright, so let's just see some of that in examples. So the first thing that I'm going to want to do is just factor anywhere where I can factor so I can see what's going to cancel out. So in this first, I'll circle this in blue, this first fraction, the numerator looks like I can't do anything. The denominator I can take out a 2, and what would be left is x minus 5. And now let's do the one in red. But instead of dividing, because see, or I just said red. The one in green. Instead of dividing, I'm going to turn that into a multiplication and do the reciprocal. So I'm going to flip-flop this fraction. So before I even factor, let me just show you what that looks like, flip-flopping that fraction. Okay, so now let's factor it. Let's factor the top, what I have circled in yellow. Factors of 30 are 1 times 30, 2 times 15, and 5 times 6. Which of those will add to get me to negative 11? Well, that would be 5 and 6 if they're both negative. So now let me just go ahead and erase that and just write the factored version of it. So x minus 6 and x minus 5. Okay? Alright, and before I start crossing off, I can already see the x minus 5 one's going to cancel with this one over here, but let's go ahead and factor the bottom. It looks like I can take out an x from both of those. I'm going to write it down here, and then I'll erase and fill it in a second. That would be x minus 6 is what would be left. Alright, now that I have it written down just so I don't forget what it was, I'll come back here and write that. Okay, and now it looks like we have a bunch of things that cancel. This x minus 5 cancels with this x minus 5, this x minus 6 cancels with this x minus 6, and this x cancels with this x. So lots of things has canceled. In fact, in the numerator, all we have left is the 7, And in the denominator, all we have left is the 2. So my answer is literally the number 7 over 2, but a bunch of conditions. X cannot be several things. We got to look back at all those things we canceled. So this one, X cannot be 6. This one that I canceled, X cannot be 0. And this one that I canceled, X cannot be 5. So it equals 7 halves as long as X is not any of these 3 numbers. If it's any of those 3 numbers, then we'll have some issues and it won't equal 7 halves. Okay, that's it. So turn it into a multiplication problem and then do the exact same thing that we did in the last video. All right, so pause it and try that on your own. All right, first step is I took this first fraction and factored the denominator by pulling out a 5 from both of those. And then in the same line, instead of making this division, I made it a multiplication problem. And notice that I flipped the second fraction. This whole thing is flipped when I wrote it over here. And that is definitely not where I'm going to end. I can now factor a bunch of things in this second fraction. So I will do that in the second line. The first fraction I kind of already did, so I'm just going to rewrite that. Let's factor the top. Factors of 8 that add to get me to negative 6, thinking in my head, would be 4 and 2. So that's going to be x minus 4 and x minus 2. And that's because negative 4 and negative 2 multiply to be a positive 8 and add to be a negative 6. So that's correct. And then the denominator, I can just take out a GCF of x. All right, and now let's start canceling. So x minus 4 cancels with x minus 4. X minus 2 cancels with x minus 2. And these x's cancel. All that's left then is 4/5 with the condition that x cannot equal, well, let's see. Here I canceled that plain x, so x cannot equal 0. Here, x cannot equal 2. Oops, when I get close to the arrow, it flips on me. And then here, x cannot equal 4. I'm going to write it up so I don't accidentally flip the page. So x cannot equal 4. As long as you have those 3 conditions on there, then your answer is 4/5, and you're good to go. Okay, cool. Let's put it all together. So here's some mixed practice of just the same exact thing. So first one, it's a problem where I just need to simplify. There's no multiplication, no division, nothing like that. So looks like in the top I can't do anything. 3x squared, there's really nothing you can simplify in that. But in the denominator, we can take an x out from both terms, and what we'd have left is 5x plus 2. And then just one minor thing is canceling. This x here would take away one of the x's up top, and so it would just be 3x in the top and not 3x squared. So this is my simplified version, except for x cannot equal 0 because I had canceled one right there. So if x was 0, then right here that would have been an issue because I'd be dividing by 0. Okay, and let's do the second one. Looks like lots of things can factor here. Let's factor the numerator. I am looking for numbers that multiply to be negative 5. Well, that would just be 5 and 1 with one of the numbers being negative. That add to be negative 4. So that shows me, okay, the 5 has to be negative and the 1 will be positive. And in the denominator, factors of 10, well, let me write these ones out because I have more options here. 1 times 10 and 2 times 5. And the ones I would add to get me to negative 7 would be the 2 and the 5 if they're both negative. So x minus 5 and x minus 2. And that's awesome because these x minus 5s are canceling. So what I have left is just going to be, actually, let me write in a different color. X plus 1 over x minus 2 with the condition that x cannot be equal to, because I had canceled this term, 5. Because otherwise that would have been an issue here in this middle step. And that's it. Okay. Last slide for today, just kind of putting it all together, doing some more division problems. I'll just do them with you. So what I want you to do actually is look at letter E and think about if you instinctively know what to do. is your mind sort of freezing and you're waiting on me to answer, or do you know what to do? If you know what to do, that's awesome that you have a game plan. There's kind of several things you could start with. You could start by flipping this fraction and making it a multiplication, or you could start by just factoring things. If you kind of blanked for a second because this looks complicated, then one of those two things that I just said is always going to be your first step. Either flip it and make it multiplication, or start factoring, or do both in one line, which is usually what I do. All right, so let me just start by factoring. I'll just factor this one. In the numerator, in just the red part I have circled, I can take out a 4x. So what would be left is x plus 3. And in the denominator, I can factor that. And factors of 3 would just be 3 and 1. But I have to add to be a positive 2. So that'd be plus 3 and minus 1. And already I'm seeing that these two factors are going to cancel, so that's awesome. Okay, so let's turn it into a multiplication problem, but I need to flip this fraction. So 5x minus 5 will go on the top, and the 4x will go on the bottom. Okay, even before I do anything else, I'm seeing that this 4x and this 4x cancels, which is also awesome. But you should also notice that this can get factored further. I can take a 5 out of both of them. And if I do that, it would be, let's see, it would be x minus 1. So let me erase this, and I'll write exactly that. So 5 parentheses x minus 1. Okay. And why that's important to make sure you go the extra step is now there's another thing canceling, this and this. So lots of things have canceled. The only thing that haven't canceled, I will circle in blue, is this x. Oh, no, I take it back. That did cancel. I just didn't put a line all the way through it. That 4x canceled completely with this 4x. Okay, so I guess the only thing that didn't cancel is literally the number 5. But I have a bunch of conditions that x cannot be equal. So let's see, what all did I cancel out? Negative 3 from this one. This one would be positive 1, so x cannot equal 1. And this one, x cannot equal 0. All right, I'm going to clear the screen and let's do part F together and then we will call it good. That's it for today's video. So let me look at this. Let's see. In this first term, I already see that this y and this y to the 7th, we can definitely do some condensing there. You know, let's just start. Let's start by condensing that. So that first fraction there, 28 cancels with nothing. X to the 4th cancels with nothing. Exponent rules here tell me to subtract the exponents. So I have y to the 1st over y to the 7th. That would be, if you subtract these, 1 minus 7 is negative 6. But then remember, negative exponents you put on the bottom by making them positive. So that was a whirlwind of exponent review. Hopefully we remember that. If not, another way of thinking about that easily is if I had 1 y up here and 7 y's on the bottom, one more I think, then one of those cancel and you'll see that you have 6 left on the bottom, which is why I wrote that y to the 6 on the bottom. So that's a more visual way of thinking about that instead of thinking about it through literal exponent rules. Okay, anyways, I got kind of long-winded, but that is the first fraction. And the second fraction, let's make that multiplication and flip it to make it easier on us. Okay? And let's condense some things together here. So 28 times 2 is 56. And then x to the 4th times x to the 5th is x to the 9th. Over, and then I can put these y's together. That would be y to the 15th. Okay, so this one's interesting because I never had to cancel anything out from the denominator. I had condensed these y's here, but that just canceled something out from the numerator, not the denominator. So in my final answer, since there was nothing I was like slashing through, nothing I canceled in the denominator, there's no restrictions on the domain that I need to say. Obviously, y cannot equal 0 because that would make the whole denominator 0. But that's not like a secret from something I had canceled out in any of my intermediate steps in this area. That's just an obvious thing that you can expect the reader to know. So I don't need to say anything special. Remember, the only time you have to specially write those extra things is if you canceled anything out in the denominator, and we did not. So we would actually end it right there. Okay? That's it today. It's a shorter video because it was kind of just reviewing and recapping, and since multiplication is since division is so similar to multiplication, it's pretty much exactly what we had just learned in the last video. All right, that's it for this week. Make sure you guys feel free to always contact me if you have any questions. Have a good one.